Advances in High Power Lasers Symposium, and that was organized jointly by myself and Dave Richardson from the University of Southampton. And what we really wanted to do there was capture a slew of applications in high power lasers. So high power lasers have really in recent years been emerging out of the laboratory, and we wanted to capture three specific areas we identified. Number one is in defense. Defense really has been driving a lot of this push to extremely high power CW, continuous wave lasers. And so we wanted to capture that. There was a hero demonstration that you may know about, which was funded under a program called Joint High Power Solid State Laser a few years ago. Got to over 100 kilowatts average power in a solid state laser. The current effort is to repeat that power level, but to go to much more compact laser architectures. And so we have a speaker right out of the Office of the Secretary of Defense here in the US, and he's going to be talking about priorities for directed energy. In other words, really transmission of laser beams over significant distances from a defense perspective. And so he's going to give the perspective of the funding agency, what they really want to see there. And then we also, on the industry side, we have a speaker from Raytheon who's going to talk about the RELY program. RELY is the program I alluded to a moment ago, which is the effort to really make those high power lasers much more compact for defense applications. And so we're going to be really excited to hear that. It's not a particular piece of work that's been given a whole lot of exposure yet, and so we're interested to see what they have to say about that RELY program. So defense is one of the three areas. The other two are in the, of course, materials processing area. You know, if you go back maybe only 8 years or so, that's when high power fiber lasers were starting to really notch up some very impressive power levels. Now they're right out there in the application space, and so we have a speaker from IPG who really dominates that space commercially, and so he's going to be talking about the applications that they are selling directly into with their fiber lasers and really where they're being used in industry. And then we also have a more forward-looking applications talk in that area from a speaker from the University of Heriot-Watt in the UK, and he's talking about using patterned light with high-power fiber lasers for machining. So that's two areas of defense and material processing. And the third and final one is in the area of what I like to call big science. So where are high-power lasers being used to really make the landmark demonstrations and capabilities come alive with these high-power lasers. And in that area we have Mike Dunn is going to be coming in from there to tell us about the laser fusion program. Really no high-power laser session would be complete without somebody coming in and telling us the status of that. I mean, those folks are right on the cusp of getting to you know, the break-even energy point, which I think would be tremendously exciting. Out of Europe, the facility, the ELI program, and that's a very broad trans-European program shooting for extremely high peak powers through ultra-fast lasers. And we're going to have Gerard Moreau coming over here to tell us about where that program is at and some of the capabilities that are really going to be advanced in the ultra-fast space by those lasers. We're just delighted with a dream team, if you like, of invited speakers we got. And so we feel very fortunate to have those folks all come in to speak at the meeting. The other special symposium I'd like to highlight today is the Space Optical Systems Opportunities and Challenges Symposium. And the reason we gave it that title is because we're really looking at systems. So in some cases, the big optical telescopes, getting those into space. In some cases, lasers actually in space. Opportunities and challenges because there are some great opportunities to really advance what's currently done in the space arena. And of course, there are still some challenges, most notably in taking a lot of the laser and optical hardware that's developed here for terrestrial applications and making sure that it's actually going to work in space, which is a really tough environment with all the radiation there and the temperature control issues. Let me highlight one or two of the things in that area. We have a speaker on the Herschel telescope. We're going to be talking about the plans for the Herschel telescope. We have a speaker, Floyd Hovis of Fibertech, who's going to come in and talk about some of the real challenges of taking lasers that are, as I mentioned a second ago, built for terrestrial applications, putting them in space when suddenly everything's got to be really lightweight and small. You've got to get heat away from the laser somehow, and has to survive in that real tough space environment. And so Fibertech, we're responsible for putting some of those lasers, all of the lasers, in fact, on the GLASS mission, which did altimetry from space for several years, a real pioneering mission. And you're going to be talking about that, as well as the GLASS 2 mission, which is the next generation altimetry mission, looking at the depth of the ice sheet. And so he's going to be talking about how one builds lasers for those kind of challenges. Also in the space arena, we have a speaker coming in to talk about laser gravitational wave measurement, and that's something, again, that really challenging thing to do in space, real big science project. And then we're going to be talking about space-based laser comm, where again you have to put challenging lasers in space. You don't have the same restriction of eye safety that you do with terrestrial laser comm. There aren't too many folks up there apart from aliens looking in the beam, and so but on the other hand, you do have to have those lasers survive with all the cosmic radiation and those other challenges up there. So again, a really interesting and really timely symposium, I think, with lasers starting now to be applied in a whole slew of applications in the space arena.